Something has been rising beneath the surface of one of Jupiter's moons, and until a few days ago, nobody could prove it existed. Not scientists, not telescopes, not even the spacecraft that had been staring at it for a decade. For years, researchers assumed they understood the heat driving the most violent volcanic world in our solar system. They were wrong, and the moment they realized how wrong, everything they thought they knew about the ocean worlds hiding in Jupiter's shadow started to unravel. Here's the question nobody in the mainstream coverage is asking clearly enough. If scientists have spent decades staring at Jupiter's moons through telescopes and flybys, how is it possible that something this fundamental, something buried just a few feet under the surface, went undetected until now? The answer to that question is not comforting, and once you understand it, you will realize that what NASA just confirmed is not a footnote. It is a preview of something much larger unfolding in the outer solar system. Let's start with what actually happened, because the reveal is more unsettling than most headlines let on. NASA's Juno spacecraft, the solar-powered probe that has been orbiting Jupiter since 2016, made two close passes near the volcanic moon Io in December 2023 and February 2024, coming within roughly 930 miles of its scarred, sulfur-streaked surface. During those close flybys, Juno turned its microwave radiometer instrument toward Io, probing roughly 6 to 20 feet beneath its surface. That single design choice, pointing an instrument built to study Jupiter's deep atmosphere at a moon instead, is what cracked the case open. Because what it found did not match anything scientists expected. Everywhere the instrument looked, the temperature rose by more than 40 degrees Fahrenheit within just a few feet of the surface, a gradient far too steep to be explained by sunlight warming an airless, rocky world. Read that again. 40 degrees. Within feet, on a moon already known to be the most volcanically violent body in the entire solar system. This is not a subtle anomaly buried in a footnote of a research paper. This is a signal that the interior of Io is behaving in a way that nobody had directly measured before, and the implications reach far beyond one small, sulfur-colored moon 400 million miles from Earth. But here is where it gets worse. Io was already infamous. Its surface is pockmarked by hundreds of active volcanoes. Its plains simmer with lava lakes, and plumes of sulfur dioxide gas blast hundreds of kilometers into space, visible even from orbit. Scientists have watched Io erupt in real time across 4 separate missions. Voyager, Galileo, and now Juno have all captured its volcanoes in the act. For decades, the working theory was simple. Tidal heating, caused by the gravitational tug-of-war between Jupiter and its other large moons, squeezes Io's interior like a stress ball, generating enough friction to melt rock and drive constant eruptions. That much was known. What was not known, what nobody had actually measured, was what that heat looked like just beneath the surface, in the layer connecting the visible chaos above to the hidden furnace below. Now think about what that means for the scientists who had built entire careers on models of how Io's interior worked. The microwave radiometer's antennas can detect microwaves across a wide range of wavelengths, from about half an inch to 20 inches. And because each wavelength probes a different depth, the instrument functions almost like an X-ray for the crust of a moon. For the first time, researchers weren't looking at surface temperature. They were looking underneath it. And when the data came back, it showed thermal emission patterns implying internal heating far too strong to be explained by anything except the moon's interior, actively churning with energy. This is not chaos. This is a process. And according to the scientists behind the discovery, the implications extend well beyond Io itself. Researchers now believe the same tidal heating mechanism that powers Io's furious volcanism may also be the very process sustaining the hidden oceans beneath the icy shells of Europa and Ganymede. Pause on that for a second. The same gravitational squeeze tearing Io apart from the inside may be the exact mechanism keeping vast oceans liquid on 2 other moons. Oceans that scientists increasingly suspect could be capable of supporting life. 1 violent, fire-scarred moon. 2 quiet, ice-covered moons, all 3 driven by the same invisible hand. Jupiter's gravity, pulling and releasing, generating heat deep inside 3 completely different worlds. What most people are not seeing is how significant the timing of this discovery is. This paper was not published years ago and quietly forgotten. It was published on July 22, 2026, just days before this very script was written, in the Journal of Geophysical Research. Planets, based on data that had been sitting, waiting to be fully analyzed since Juno's close encounters back in late 2023 and early 2024. Scientists had the raw numbers for over 2 years before they were able to confirm what they were actually looking at. That delay alone should tell you something about how difficult it is to interpret signals coming from 400 million miles away, buried under alien ice and alien rock, transmitted back through a radiation environment that is trying to kill the very spacecraft measuring it. And that radiation is not a minor detail. According to informed sources within NASA's own press materials, Jupiter is surrounded by a gigantic magnetic field 20,000 times as strong as Earth's. 20,000 times. That field traps charged particles into radiation belts so intense that they can fry spacecraft electronics, scramble sensors, and degrade instruments with every single pass. Juno was built specifically to survive this environment, shielded behind a titanium vault, and even then, engineers know its instruments are slowly being cooked alive by every orbit. Every data point pulled from Io, Europa, or Ganymede is a data point wrestled away from one of the most hostile electromagnetic environments in the entire solar system. This is not routine science. This is closer to intelligence gathering conducted inside a war zone, except the enemy is physics itself. And this is where everything changes, because Io was never the true target. The real story, the one most coverage buries beneath the Io headlines, is Europa. NASA's Europa Clipper, the largest spacecraft the agency has ever built for a mission to another planet, launched on October 14th, 2024, aboard a SpaceX Falcon Heavy rocket, and it is currently mid-flight, deep into a 5.5-year journey that will carry it 1.8 billion miles across the solar system. Think about the scale of that number for a moment. Nearly 2 billion miles, executed with the precision of a machine that cannot be repaired, cannot be rerouted by a human hand, and cannot afford a single miscalculation. To make that journey possible without carrying an impossible amount of fuel, Europa Clipper is using a sequence of gravity assists, flying close to other planets and stealing a small amount of their orbital momentum to build speed, like a slingshot stretched across the void. It swung past Mars in February 2025 to adjust its trajectory, and it is now lining up for an encounter with Earth in December 2026, its final gravitational slingshot before being flung out toward Jupiter. That means right now, as this is being written, humanity's most ambitious ocean world mission is threading a path through the inner solar system, borrowing gravity from planets we already understand to reach a moon we barely do. Once it approaches Jupiter, the spacecraft will slip past Ganymede itself, using that moon's gravity to help slow down and settle into orbit around Jupiter, currently projected for April 2030. Read that again. It will use one alien moon's gravity to reach another. This is not a straight line journey. It is a calculated multi-body dance choreographed years in advance, where a single navigational error compounds across billions of miles, and where the smallest miscalculation near Ganymede could mean the difference between a successful orbital insertion and a multi-billion-dollar mission drifting silently past Jupiter forever. And here's the part that should genuinely unsettle you. Recent analysis has revealed that Europa Clipper's hardened electronics may be more vulnerable to Jupiter's radiation than engineers originally expected, a late-breaking complication discovered after the spacecraft had already launched, already committed to its billion-mile trajectory, with no way to turn back and no way to swap out a single circuit board. Think about what that means. A mission a decade in the making, carrying 9 separate scientific instruments, is now flying toward the most radioactive environment in the solar system, with hardware that engineers themselves are not fully certain will survive the very radiation belts it must cross to complete its mission. Why does any of this matter? Because of what lies underneath Europa's ice. Scientists believe a saltwater ocean exists beneath Europa's icy crust, one that may contain more than twice as much liquid water as all of Earth's oceans combined. Say that number out loud. Twice the water of every ocean on our entire planet, hidden beneath a shell of ice on a moon smaller than our own. Scientists have also found evidence that Europa may host organic compounds and energy sources beneath its surface. The 2 other ingredients, alongside liquid water, that many astrobiologists consider essential for life as we understand it: water, chemistry, energy. All 3 potentially present on a single moon orbiting a hostile gas giant nearly 500 million miles from the sun. This is the sentence that should stop you. If Europa Clipper confirms these conditions are not just plausible but actually present, it does not just answer a question about one moon. According to NASA's own mission scientists, if the mission determines Europa is habitable, it may mean there are more habitable worlds in our solar system and beyond than previously imagined. Not just more moons, potentially more worlds across the entire universe. A single spacecraft, orbiting a single moon, could quietly rewrite the statistical odds of life existing anywhere else at all. But Europa is not traveling alone in this story, and this is where the narrative widens in a way most viewers never expect. Europa is only one of 3 large moons caught within the same crushing band of radiation generated by Jupiter's magnetic field. Io, Ganymede, and Callisto orbit through variations of that same hostile zone. Each of these moons has been shaped by the same gravitational violence, yet each has responded in a completely different way. Io burns. Europa freezes over an ocean. Ganymede, the largest moon in the entire solar system, larger even than the planet Mercury, does something even stranger. According to newly surfaced research referenced in recent coverage, Scientists using the James Webb Space Telescope have discovered that Jupiter's moons leave cold footprints in the planet's auroras, and separately, that auroras on Ganymede itself resemble Earth's own northern lights. Let that settle for a moment. A moon, hundreds of millions of miles from the sun, orbiting a gas giant with a magnetic field 20,000 times stronger than our own, is generating auroras that mirror the exact phenomenon we see dancing over the Arctic Circle. Ganymede is not simply a passive ball of rock and ice being dragged around Jupiter. It is an active, magnetically alive world, generating its own internal magnetic field, the only moon in the entire solar system known to do so, strong enough to carve visible light shows into its thin atmosphere. And here is what most coverage glosses over entirely. This magnetic field is believed to be one more piece of evidence for the same hidden ocean theory now surrounding Europa. If Ganymede has its own internal magnetic field, and Juno's newest data suggests tidal heating fuels subsurface oceans on the moons of giant planets such as Europa and Ganymede, then the picture assembling itself in front of scientists is not one hidden ocean. It is potentially two, sitting side by side, both driven by the same crushing gravitational forces radiating out from Jupiter itself. Two oceans, two moons, one shared power source ripping through their interiors like an invisible current running beneath everything we can see from Earth. Now escalate that thought one step further, because the Io findings are not isolated from this bigger picture either. Researchers believe the same tidal heating process that creates Io's extreme volcanism also plays a role in maintaining the underground oceans beneath the icy surfaces of both Europa and Ganymede. This means the most violent, fire-ravaged moon in the solar system, and the two quiet, ice-locked ocean worlds beside it, are not separate stories at all. They are three expressions of the exact same underlying mechanism: the relentless gravitational squeeze of Jupiter, transforming raw orbital mechanics into heat, and heat into the conditions that might, just might, be capable of sustaining life. Let's go deeper into how strange Io's surface actually turned out to be, because this detail rarely makes it into the headlines, and it deserves attention. Prior to this new data, Io was known primarily for its towering mountains and violent volcanic terrain, but the microwave radiometer revealed that much of the moon's surface is remarkably smooth, with expansive flat regions stretching 60 miles or more. Scientists have compared these unexpected plains to the Great Plains of North America, an image that feels almost absurd once you picture it. A moon famous for spewing lava hundreds of kilometers into space, simultaneously hiding stretches of terrain so flat and undisturbed that they resemble farmland back on Earth. Why would a world defined by chaos also contain regions of near-total geological calm? Nobody has a confirmed answer yet. And an unanswered question, sitting quietly inside a peer-reviewed paper, is exactly the kind of detail that tends to get overlooked until it turns out to be the key to something much larger. There's another detail buried in the data, one that deserves far more attention than it has received. A December 2024 paper, based on gravity data Juno collected during those same Io flybys, revealed that Io's volcanoes are powered by individual, separate magma chambers, rather than by one single connected global ocean of molten rock beneath the surface. Before this, many scientists assumed Io's interior functioned something like a shared reservoir, one continuous sea of magma feeding hundreds of volcanoes uniformly. That assumption is now gone. Io's interior is fragmented, compartmentalized, behaving less like a single furnace and more like an entire network of independent, isolated fires, each one burning on its own schedule, each one driven by localized stress rather than shared plumbing. That single correction reshapes how scientists model not just Io, but every tidally heated world discovered anywhere in the universe going forward, because it means tidal heating does not necessarily create uniform interior conditions. It can fracture a moon's interior into isolated, unpredictable zones of extreme heat. Now here is where the story pulls back to the present moment, because none of this is finished. This is not a closed case. According to the research teams involved, Juno had completed its 85th close pass of Jupiter as of July 5, 2026, a full decade after first entering orbit around the planet in 2016. A spacecraft engineered for a much shorter primary mission has now spent 10 years absorbing punishment from the most brutal radiation environment humanity has ever sent a machine into voluntarily. And it is still delivering data that forces scientists to rewrite their models. 10 years, 85 passes. And the biggest revelations may still be sitting, unanalyzed, inside data already transmitted back to Earth, waiting for the right researcher to notice the right anomaly. Meanwhile, Europa Clipper is still years away from even arriving. Once it reaches Jupiter in 2030, the spacecraft will orbit the planet and conduct 49 close flybys of Europa, carrying 9 separate science instruments alongside a gravity experiment built into its telecommunications system, with every instrument designed to operate simultaneously during each pass. 49 separate opportunities to gather data on a single moon. 49 chances for something to go wrong, and 49 chances for something extraordinary to be confirmed. Every single flyby will happen inside that same 20,000 times stronger than Earth radiation field with instruments that engineers already admit may be more fragile than originally designed for. And this is where the mission gets even more layered, because Europa is not the final chapter of this exploration effort either. According to Johns Hopkins Applied Physics Laboratory, the scientist leading one of Europa Clipper's camera teams is simultaneously leading NASA's Dragonfly mission, a separate spacecraft heading to Saturn's moon Titan, currently slated to launch no earlier than 2028. Think about what that means. The same scientific minds mapping Europa's icy, chaotic surface are already preparing humanity's next journey to an entirely different moon around an entirely different planet. This is not a single mission. It is a widening campaign, an accelerating pattern of exploration reaching further and further into the outer solar system, moon by moon, ocean by hidden ocean. What most people are not seeing is the sheer historical weight sitting underneath all of this. These 4 moons, Io, Europa, Ganymede, and Callisto, were first observed by Galileo Galilei in 1610 through a handmade telescope when he initially mistook them for distant background stars before realizing they were orbiting Jupiter itself. That discovery did not just add 4 new objects to a star chart. It directly undermined the dominant belief of the era that Earth sat at the center of the universe. 400 years later, humanity is once again pointing instruments at those same 4 moons, and once again, the discoveries emerging from them are quietly dismantling assumptions we didn't even realize we were making. This time, not about the structure of the cosmos, but about where in that cosmos life might actually be capable of existing. Let's slow down and connect every thread of this together, because the full picture only becomes visible once you stop looking at each discovery in isolation. Io's newly measured subsurface heat is not just a fact about one violent moon. It's physical proof of the exact tidal mechanism scientists believe is simultaneously keeping Europa's ocean liquid beneath its ice, and possibly doing the same for Ganymede's suspected ocean as well. Ganymede's newly observed magnetic field and Earth-like auroras are not just a curiosity. They may be direct evidence of an active, energetic interior consistent with a hidden sea. Europa's chemistry, its organic compounds, its potential energy sources, are not isolated data points. They are the final ingredients astrobiologists have been waiting to confirm, sitting quietly beneath ice that a spacecraft the size of a basketball court is currently racing across billions of miles of empty space to investigate directly. Every discovery reinforces the next. Every moon tells part of the same story. And that story keeps building toward one central, almost impossible-sounding question. Are we, right now, in the middle of gathering the first hard evidence that life exists somewhere else in our own solar system? Nobody, not NASA, not the researchers who published these papers, not the scientists staring at Juno's decade of accumulated data, is willing to answer that question yet. And that hesitation itself tells you something. This is not a group of people rushing to sensationalize a finding. These are careful, methodical scientists sitting on top of data that keeps pointing in the same unsettling direction, refusing to say the word life until every alternative explanation has been exhausted. That kind of caution should not make you less interested. It should make you more interested, because it means the case being built here is not built on hype. It's built on repeated, independent lines of evidence, arriving from 3 different moons, using 3 different instruments over the course of more than a decade, all converging on the same possibility. But here's the part of this story that nobody can control, and it's the part that should stay with you long after this ends. Europa Clipper still has to survive its journey. It still has to complete its final gravity assist past Earth in December 2026. It still has to slip past Ganymede's gravity with pinpoint precision in 2030. Its potentially vulnerable electronics still have to withstand a radiation environment 20,000 times stronger than the one protecting our own planet, across 49 separate close encounters with the very ocean it's traveling to study. Juno, already a decade into a mission built for far less punishment, has to keep functioning long enough to deliver whatever secrets remain buried in its collected data, secrets that took scientists more than 2 years just to properly interpret from a single pair of flybys. And somewhere in the space between now and 2030, on a moon smaller than our own, hidden beneath a shell of ice, twice the water of every ocean on Earth may be sitting in darkness, waiting to be found, or waiting to reveal that it was never capable of holding life at all. Which outcome are we actually racing toward? Nobody knows yet. Not NASA, not the scientists who spent 2 years decoding a single set of temperature readings from Io, not the engineers who only recently discovered their own spacecraft might be more vulnerable than they thought. All anyone can say for certain, right now, in this exact moment, is that Jupiter's moons have already forced humanity to rewrite what it thought it understood about volcanic interiors, hidden oceans, and the very forces capable of sustaining life beyond Earth. And the mission carrying the tools to actually confirm what's down there hasn't even arrived yet. It's still out there, somewhere between Mars and Earth's next flyby, gathering speed, carrying instruments that may or may not survive what's waiting for them. The countdown has already started. We just don't know yet what it's counting down to.